subgraph. Everyone try to alert. We are starting the class. Subgraph. A graph G is said to be a graph G is sorry from a given graph we can derive the subgraph. We can derive subgraph of G. Whose subgraph? G subgraph by removing some edges and vertices. For example, you have like this one graph. Example, this is a one graph. A, B, C, D. This is a one graph. So it's a subgraph. Subgraph, you can remove any sum of the edges and vertices. For example, A, D, C. So this is a subgraph. This is a subgraph of the given graph. This is a G graph and its a subgraph is this one. So by removing some edges and vertices, whatever you got resultant graph is called as a subgraph. Next, union of graphs. Union of graphs. So what is a union of graph means? We'll illustrate this by one example. For example, there is a one graph B to C, A, B, C. Next D, E. This is a one graph. Next A, B, C. Next A, B, C, D, F. So now this is a G1 graph, this is a G2 graph. So now we have to do G1 union G2. G1 union G2. So G1 union G2 means whatever the common edges will be there, that you have to write one time. Any new edge will be there in any one of the graph, you have to add them. To understand this, for example, there are two sets is there. A is a 1, 2, 3. Next B is a sum -1, 2, 3, 4. What we will do? We write all the A union B. We write all the values which is a 2 times repeated. We write one time. For example, 2, 3, 2, 3. You have to write one time. So -1, 1, 2, 3, 4. Here also the same thing we will do. AB edge is there, AB edge is there. You have to write one time. Okay, AB edge. Next BC. Both of the graphs is there. Next D edge. Sorry, vertex D, AD edge. Next here B to E edge. B to E edge. Next D to E edge. You have to combine the two graph. D to E edge. Next B to D edge is there here. In the second graph, B to D. So write that B to D. Next first graph only C vertex, but here C to F is there. You write all C to F. Now check it. It is a combination of first graph and second graph. So therefore, this is called as a G1 union G2 graph. So union of two graphs. AB, BC repeating one time. AB, BC. AD is there repeating. AD one time. Okay. Remaining DE. Here DE is there. The DE. Okay. Next CF in the second graph, CF is there, CF. So like that, you have to add all the edges and vertices which are there in the first and second graph. This is called as a union of the graphs. Next, we'll see the coloring of a graph. Next, coloring a graph. So, what is a coloring a graph means? The assign of colors, the assign of colors to vertices. We make vertices as a color. The assign of colors to vertices of graph G such that no two adjacent vertices get same color. Okay, so this is a coloring graph definition. The assign of colors to vertices of a graph such that no two adjacent vertices get the same color. So you assign colors to graph in such a way, so beside side to side vertices don't get the same color. Adjacent means, for example, A, B, this A vertex, B vertex. These both want to be get different colors, not same color. Okay, so that is called as a coloring of a graph. You color the graph in such a way no adjacent vertices get the same color. Okay, for example, these AB and the AB are joined by one edge. So AB are the adjacent vertices. So AB we have to get different colors. For example, A has a red color, B has a some yellow color. Both of them not get the same color. That is a condition for giving the coloring of a graph. Next, what is that means? In this only, the smallest number of colors, required to color a graph G is called its chromatic number. It's a chromatic number of that graph it is denoted by zeta of G. Zeta. Okay, so what is this one means? Zeta of G, chromatic number. That means how many number of smallest number of colors required to color a graph, that is called as a chromatic number. Smallest number of colors means no adjacent vertices get the same color. Based on that condition, no adjacent vertices get the same color. Based on that conditions, how many number of colors need? How many number of colors you need? That is called as a chromatic number. To understand this, we see one example. For example, okay, there is the four vertices will be there. Now you have to color the graph. So What is the condition? You color in such a way no two adjacent vertices get the same color. So first assume this, I am giving this for red. For this vertex I am giving the color red. So when you're giving red, you don't have right to give red for this side or this side. Adjacent won't get the same color. So it is a red means you can give here green color for this vertex. Next, when it is green, you can also here give green. Okay. So now check it. Beside vertices, you have any same color, red, green, green. Adjacent vertices have the different color. Now come this one. Suppose if you give red, a red, what will happen? This is okay, green, red. But what is happen? These two are also adjacent. For example, this is a vertex, B vertex, C vertex, D vertex. So what will happen? AC get the same color. Adjacent AC or the adjacent vertices, they get the same color. It is not permitted. So now stop that sharing. So now somebody sharing, you just stop that. You 85 or who is that? So now what you have to do means you have to assign some other color. So what is that color? Red, green already given. You can give yellow. Okay. That means we assign three colors: red, green, yellow. Check it. Red, green, red, yellow. So no two adjacent vertices have the same color. Therefore, this is called as a coloring of a graph. If you have the sketch, you can write like this. Okay, this is a red. Next, I don't know exact color. This is a green. Okay, this is also green. Okay, next this is a yellow. When you're doing problem, you just write its name, not it is needed coloring. You just write yellow, green, that's all. Okay, red, yellow, green. So how many colors we need? How many colors we got? Three colors. So number of colors is that is chromatic number. So how many numbers you got? Zeta of z, zeta of z equal to 3. Smallest number of colors. Smallest number of colors is how much? 3 colors we required. So to color this graph. So 3 colors is required. Those 3 is called as a chromatic number. Okay. Next. I think someone sharing me sharing off చేయండి శ్రావ్యనా 567 or something. It is a request that everyone video sharing off చేయండి. I'll explain what is that reason later. So now second, for example, there is a one graph. There is a one graph. Wait a minute. A, B, C, D. This is a vertex D. D, F. Next, this is G. Next, E. Okay. One more. Now, listen here. This is a one graph. For this graph, you have to color. So now it is your choice. You can give any colors, but the condition is no adjacent vertices get the same color. For example, I'll try to give here some. Assume I'm giving here yellow. For G vertex, I'm giving yellow. So when you give yellow, you cannot able, you don't have the right to give yellow for the adjacent vertices. So for F you cannot give, you cannot give for E, you cannot give for A also. Why? Because there is adjacent vertices. So G given means no right to give F, E, G. So I give yellow here for D vertex. Okay. So now when you given yellow, you don't have the right to give yellow color for B, C. Why? Because they are adjacent vertices. You don't have right to give yellow color for A also. Why? Because G and A, there is a one edge is there. There is a back side. What is there? There is a one edge is there. So you don't have the right to give them yellow color. So that means you can choose an. Yes.
నా పెళ్లి యుఎస్ లో ఫోన్ మస్తాడే నా పెళ్లి యుఎస్ లో సరే వార ఫాదర్ నా పెళ్లి యుఎస్ లో
హలో మీరు మీ పర్సనల్ విషయాలు మీరు పక్క వాళ్ళ మీ ఇంట్లో వాళ్ళతో ఏదైనా మాట్లాడితే మీరు మ్యూట్లో పెట్టుకోండి. నేను ఇక్కడ క్లాస్ రికార్డ్ చేస్తున్నాను. నాకు మళ్ళీ ఏమవుతుందంటే ఆ క్లాస్ రికార్డింగ్ అంతా నేను మళ్ళీ ఎడిటింగ్ చేసుకుంటూ కూర్చోవాల్సి వస్తుంది మీ మాటలని. ఇట్ విల్ టేక్ ఫర్ మోర్ టైం. ఓకే. సో నాకు అన్నెసరీ మళ్ళీ వర్క్ పెట్టకండి. మీ మాటలన్నీ ఎడిట్ చేసుకుంటూ కూర్చోవాలి. నేను ఇంకో సాఫ్ట్వేర్ వాడుకుంటాను. సో నౌ నెక్స్ట్ here you got yellow. Next, now no right to give yellow for other vertices. So now what you have to do means you take from other color. Yellow given, I'm giving here green. So when you given green here, for C you don't have the right to give green. So for the F you can give green. Okay. So now check it. For A we cannot give green. F we are given. Next, can I give green for B? No chance. Why? Because when you give green for B, A, B are the adjacent vertices. Can I give E green color? No. Why? Because E, F are the adjacent vertices. That means we have to choose another color. So I'm choosing some red color. So choose red. For example, I'm giving here red color. So when you give a red color, can I give red color to B? No. Can I give red color to C? Yes, I can give red color here. Okay. So now, can I give for B red? No. Yellow? No. Why? Because the adjacent. Green? No. Green means A, B are the adjacent. So I want to be choose another color. So blue color. So totally how many different number of colors we use it? So totally how many different number of colors we use it? 4 colors: green, red, yellow, blue. So smallest number of colors to color a graph, how many you got? 4. So chromatic number zeta of G is equal to 4. So this is a chromatic number of the coloring of a graph. Is there any doubt in this topic? Anyone can respond? Boys and girls, now you can speak. Is there any doubt?
No, sir.
ఓ సార్
Now next we are going to discuss one more topic, dual of a graph. Listen here. Dual of a planar graph. Dual of a planar graph. So what is a dual of a planar graph means? First you have to know planar graph. I already said in the previous classes, planar graph means a graph is said to be the planar graph. No two edges cross each other. For example, if you take like this, A, B, C, A, B, CD. So now, is it a planar graph? Means first you have to derive it whether it is a plane. Sometimes planar graph it look directly, sometimes not. So what you have to do? A, is it possible to draw without crossing? A, B, C, D. You can draw A to C one edge. Next, what is there? D to B is there. D to B you can draw from outside. Therefore, given graph is a planar. So that means graph is a planar means no two edges cross each other. So that is called as a planar. Okay. So now, what we are discussing is dual of the planar graph. We are going to discuss the dual of a planar graph. There's a listen here. For the dual of a planar graph, you remember some three conditions. Based on this we will draw. For example, this is a one graph. Assume this is a one graph. So the graph you divide regions. Assume this is a F1 region, F2 region, F3 region. So the condition is, if the regions are separated by one single edge, then draw one dotted edge in between them. Listen carefully, the condition, first condition, this is a one graph, this is a one graph, F1 regions are F1, F2, outside is 3. First condition, if the two regions are separated by single edge, then draw one dotted edge between them. One dotted edge between them. That is first condition. Second condition, if two regions, for example, this is a one graph, two regions are F1, F2. If the two regions are separated by two edges, what is there? There is a one common edge is there. Assume that this is a F1, F2. So F1, F2, there is a common edge will be there, separated by these two. So you can draw what dotted line. Next, here also one common edge will be there. So you draw one dotted line. Okay, this is a second condition. First condition, listen carefully. If the regions are separated by one single edge, draw one dotted line between the two regions. Second condition, if the F1, F2 regions are separated by two edges, then what you have to do means, you have to draw the two common dotted lines. So F1, F2, here one dotted line and here one dotted line. How many edges will be there? They are separating the region. That many dotted you have to draw. So for this graph, F1, F2, common edge will be there, this one. So draw one dotted line. Here also one common edge will be there, outside totally F2. So draw one line. Okay. So that is the second condition. Third condition, what is the third condition means? For any edge lying entirely in one region, for example, this is a wait a minute. For example, if you know these two conditions, you can able to draw any dual graph easily. F1, F2. Here some edge will vertex will be there. Any vertex which is totally lies inside the region. So what you have to do means, the region F1 to covering that vertex, you draw one loop. That is the third condition. So we are drawing the dual of the planar graph. When you are drawing the dual of the planar graph, you remember these three things. One more time explaining. If you know this one means, you can draw any planar graph duals very easily. So what is that means? First condition, F1, F2, F3, three regions will be there. So two regions are separated by one common edge, draw one dotted line. If F1, F2, two regions, they are separated by two edges. So draw two dotted lines like this. If F1, F2 separated by some edges, one vertex totally lies in that set only. one vertex lies totally in that region only. So what you have to do means you draw one loop crossing that edge. So these are the three conditions for the drawing dual of a graph. So now we do one problem on this. Sorry. The book you can write R1, R2 are also regions. F1, F2, your choice. Listen here. Find dual of this graph. Okay. You name regions F1, F2 or R1, R2. If you want, I'll write R1, R2. This is a R1 region, R2 region. మీరు ఏదనుకుంటారు F1 అనుకుంటే F1 వాళ్ళు ఎందుకని. So now F1, this is a F1 region. Next F2 region. Next F3 region. Next F4 region. Next F5 region. Next F6 region. So now listen here, first condition, these are all the regions F1, F2, F3, F4, the outside is F6. F1, F2, they are separated by one common edge. They are separated by common edge. No? So draw one dotted line. I'll use another color. So draw one dotted line. Okay. Next, F2, F3 separated by one common edge. So draw one dotted line. Okay. So now, next, F3, F4 separated by one common edge. Draw one dotted line. Next, F2, F6 separated by one common edge. Draw dotted line. F6, F5 separated by one common edge. This is one edge, single edge. So dotted line. Next, F1, F4 separated by one common edge. Draw one dotted line. Next, the some vertex will be there which is totally lies in this region only. So you draw one dotted line which intersects the edge. Okay. Next, F1, F5 are the separated by this edge. F1, F5. So draw one dotted line. Okay. So now, is there any other? F1, F2 completed, F2, F5. Okay. So now, is there any other thing? So this dotted, whatever the dotted graph is called dual of given graph. What is the dotted lines you got? The dotted edges graph is called dual of the given graph. If you have any doubt, if you want you have any doubts on this? Hello. Meeting is going to be
No, sir.
Meeting is going to be disconnected within 1 minute. Again, you rejoin. We'll discuss this is one more time. Less than 1 minute, it is going to be disconnected. Wait a minute, it is disconnecting. Less than 1.